Well, welcome to PDC 2008. This session is the Inside the Olympics, basically an architectural and development review. There's also probably 25% of the talk that's more of kind of like the dirty laundry, kind of opening the kimono, telling you some of the tough parts of this project. My name is Eric Schmidt. I work in the developer and platform evangelism team. I run a small little group of folks, and we focus on media and monetization projects. So we worked on the Olympics. We worked on CBS Sports College Player and the Democratic National Convention, and a bunch of other stuff. Jason Seuss is one of the guys on the team. He was the lead on this project, working with myself and a couple other folks. And he is unfortunately not here today. He is in New York. That's where I was yesterday, doing some work, and then we traded off. So I will give him your best after this session. So how many people use the Olympics player during August? All right, good many of you. That's cool. What I'm going to do just for a couple minutes is just kind of walk through the player super quick so everyone has context about the rest of the session. I'm going to flip back over to my laptop here. I've already clicked into a video, and you can kind of see the video quality is jumping up and down because the bandwidth is really horrible in here. So this is our adaptive streaming technology at work. Yesterday we did an announcement at Digital Hollywood where we formally released a platform technology called IIS Smooth Streaming. I'll get into that more later. But functionally, what we built for NBC. Oh no, I gotta hold on a minute. Welcome to. Where's Comcast at? There you go. All right. Where do I live? Seattle. Done. Okay. So functionally what we built for and with NBC was this pop-up experience that was housed or surrounded by a bunch of metadata. This was the lean-in experience, so people could kind of lean in, look at related content. During the games, there was live commentary and play-by-play. There was also live advertising being inserted here, so we get to see this Tropic Thunder video over and over again. This was the pop-up experience, and if you didn't have Silverlight on your machine, you were also could have been presented with a Windows Media Player experience. It was basically our fallback experience for folks that didn't want to install Silverlight. Then you could flip over into what we call enhanced mode, which was 16:9 video. I'll talk a little bit later about why we didn't have full screen. But what this functionally gave you the ability to do was quickly seek and search through video with limited or no buffering. You could go into the live video control room. At the peak of the Olympics, we had 17 live events happening at one time. So if you compare that experience to what you would get on television, you had the ability to go in and fundamentally switch and watch 17 different channels simultaneously and then fill up these side windows off to the right with related video. Let's go ahead and... One of the other things we did was we provided a graphical navigation on top of all the content that was coming out of Beijing. There were 34 top-level events, and we consolidated them down using the icons that the IOC had created. But you could go in and find additional content. So I really like rhythm gymnastics for some reason. Go ahead and pop a rhythm gymnastics window down into picture-in-picture. So it was another thing that we implemented was that ability to basically stay in one particular piece of content but kind of snack on some additional content on the side and then seamlessly swap those two videos. Another thing that we did is we took all of the content that was seen on television, the Bob Costas high production value content, and we pushed that back out to the web. And finally, and this is a core section of this talk, is we implemented this concept of the highlights factory. So there were 2,000 hours roughly of live content that came out of the 19 days of the Olympics. And what we ended up doing was building about another 2,200 hours of highlights on top of that content. So you could go watch a full game, say a full ping pong match end-to-end or a full soccer game, or come into this highlights area and just look at the top 10 goals for a particular day, something of that nature. And the reason that we did it was for two reasons. One, there was a lot of content that was seen on television, so why would you go to the web and watch the same thing if you already saw it on TV? So this is providing additional value. And then two, just to help people consolidate and shrink time. So you may not have 90 minutes or 110 minutes to watch a soccer match, so you could just come in and watch the highlights. And this was all done in real time, published anywhere between 10 and 20 minutes of an event being done. And I'm going to walk you through the architecture of how we built this. I have a massive amount of information to share. So during the talk, and I know this is kind of discouraged, but I want to make sure that your questions get asked and answered, especially if they're in context of something I'm talking about. So please feel free to raise your hand. And if it's going to add value, I'll answer it in real time. So what I'm going to talk about quickly is just setting up the business imperative. Why did we take on this project? What did NBC want to get out of it? I'm going to get into what we actually built. I'm going to walk through this whole concept of kind of where do babies come from, or where do videos come from, because there was a massive amount of content that was created, and it just wasn't as simple as kind of shooting some camera and dropping in a tape into a D5 tape and dropping it down and then putting it on the web. It was slightly more complex than that. I also want to talk about how we managed the ship, because once we turned this engine on and we started driving, the Olympics were functionally 19 days long. It was a 24-hour event. It was managed multiple time zones away from New York and also Redmond. So how did we manage this thing? And then give you some of the dirty details about what we learned. So the business perspective, this was pretty interesting. We sat down with NBC really in December to meet with their business execs and also all their IT folks and said, what do you want to get out of the Olympics? And to compare and contrast, in Torino, the previous Olympics, they did about 2 hours of live and put about 20 hours of content onto the web. For Beijing, they wanted to put every minute of every sport live on the web and then do this highlight factory plus take TV content and take that to the web as well. So functionally like around 30 hours of content versus 5,000 hours. It had never been done before. And their IT people were just freaking out. They're like, how the hell are we going to do this? Like, we could barely do Italy, and now you want to go do something like this, and oh, by the way, it's in China, and we have no infrastructure there right now. The other things they wanted to do was make it look HD quality. So anyone can kind of do YouTube quality video today with the infrastructure and bandwidth that's out there. But they wanted HD quality. They wanted to be able to compete with other folks that are in the sports broadcast business. Not to mention they can deliver HD on the television. Why can't we deliver it on the web? They wanted a breakthrough user experience. So it just wasn't about watching video. It was about immersing the user to drive dwell time. And they wanted to make it feel solid state. So it had to look and behave like television. Things like buffering. They didn't want to annoy the user there. They want to be able to seamlessly switch between channels just as fast as you can do it on your Comcast box. They also wanted to reach the largest audience as possible. So at the time, Silverlight was still in beta mode. And we had a long discussion about, well, why would we want to put a beta product in front of millions of users and lose potentially half of them simply for the fact that they're just going to say, no, I don't want to install this thing. I don't know what it is. So we had to have a solution for that. Oh, by the way, they wanted to leverage as much assets as possible because they didn't have a lot of money. Drive high dwell time. They wanted quality impressions for their advertisers because everyone knows who NBC is on television, but who's NBC on the web? And they know what Olympics are on TV, but what are the Olympics on the web? So that had to be quality. Oh, by the way, it needed to be innovative. So at the end of the day, what happened? Well, the one thing that we did to drive traffic was we pulled MSN into this process. So it was fundamentally the Silverlight team, the developer division team, kind of pulling all of our platform assets together, and then we locked hands with MSN and said, hey, and MSN really drove this part of the conversation, but how can we take the value of our MSN network? We have one of the most respected worldwide consumer networks on the globe. How can we take that traffic and fundamentally funnel it over to the Olympics in a seamless manner? And what they did was for the 17 days of the Olympics, they had this dynamic programming banner up at the top to funnel traffic over. And what we ended up doing was we drove 1.3 billion page views, fundamentally in that 17 days. The first 2 days were startup. We had 50 million unique visitors. We had 70 million videos watched. This was a really interesting stat. So on average, users viewed per session around 27 minutes worth of video. The average for the other sites outside of the US that were basically doing YouTube-like distribution was around 3 to 4 minutes. So at the end of the day, the model that we built, the user experience that we built out, really proved that delivering 16:9 content, letting users have immediate access to content, letting them seamlessly share, the model proves out that you can drive dwell time if you build the right mousetrap. We delivered over 600 million minutes of video. This next stat is really, really interesting. During the last week, there were over 5,000 unique clips viewed during the last 7 days of the Olympics. At day 0, we really had no clips of interest other than player bios. So those were kind of interesting, but you watched them once and that was it. So at day 0, as we started to get into live production, more and more clips started to get into the system. And by the end of the Olympics, we had this long tail effect where people coming in and watching one particular, say, live event and then going out and continuing to snack on a bunch of other clips that they found of interest. We also, we didn't participate in this process, but from a workflow perspective, we helped enable driving additional delivery beyond the browser to mobile devices. We had 130,000 peak streams. This is by no means a record. The March Madness and CBS still holds the record for number of peak streams. But what we were able to do in this case was, unlike March Madness, we know CBS knows pretty much fixed what their audience is going to look like, and they can go out and build out capacity. In this case, we had no idea what the capacity was going to be. We're going to take every minute, every sport, and put it on the web and say, all right, it's here. Bring it on, and we'll try to deal with as much traffic as possible. So we actually were built out for about 2.5 times of where we hit at peak. Ultimately, what that meant, great user experience. There was no waiting room. There was little buffering for live. We did have a couple outages here and there, but that was quickly resolved. There was basically just general, dealing with the internet. But this 130,000 peak streams is definitely in our wheelhouse. And we delivered over 3.4 petabytes of video. This number is around a little over 4 because all these numbers were just up through the 25th. And the interesting thing was we actually had still a massive amount of traffic 2 weeks after the Olympics because everyone could come and watch all the content. None of it was live anymore, but it was all available for rewind. You had a quick question?
Who are your mobile partners for delivery?
I don't know. I can get you we helped just on the internal workflow, making sure all that video was pushed out. I know it was one company. I know that you used Amazon's services for distribution and management, but I don't know the actual name. So what I want to do is basically walk through the video workflow. So first thing, we had 2,200 events, like 2,200 individual, like walking out on the field, blow whistle, start, et cetera, covering 25 different sports, around 34 different categories. Most of those events had multiple camera angles to them. It was 19 days of live production. We were going to basically, and I already said this, do this kind of 2,000, 3,000 split to get 5,000. And we needed to have redundant, scalable content delivery. So the fact that we were in Beijing, we had to backhaul all this content to New York, and then that had to get redundantly and scalably delivered to the rest of the United States. This slide is important to understand as we get into the workflow. There were fundamentally 4 different things, 4 different types of video that we were delivering. Live, which was delivered over Windows Media Services at a fixed bandwidth. This accounted for that 2,200 to 2,000 hours bulk content that I talked about. It was synchronized with live play commentary. So at each event, we had commentators that had a little window, and they would sit there and say ball 1, ball 2, et cetera. They would do ad insertions, and they'd create a little XML file, and that would get pushed through a content management system. And as the video was playing, we'd sit there and update the player and pull in the new XML file. And that's how you got the live commentary. And I'll show you in more detail how we did that. Then we took that live as it was happening, and we encoded it into something that we called rewind streams. And those were encoded using, at the time, we just called it adaptive streaming. We basically took the Windows Media file and chunked it down into 2-second pieces and produced a couple different bandwidth streams or files for rewind. And then those were served back up. The content that I was just showing you was rewind content. The third type was highlights. So this is basically light touch craft edits. NBC pulled in 50 college students. They're basically, what was the word? Interns. I kept on calling them volunteers. They were absolutely not volunteers. They went out and scoured the best kind of interns, both in sports and also video development across the world, housed them, put them in 30 Rock for those 17 days, and enabled them to go create these kind of light touch but very emotional highlight reels. And I'm going to show you the Phelps video a little bit later, but this was one of the amazing things that came out of this workflow is that they can empower, basically a 22-year-old kid. A lot of them weren't from the United States. A lot of them didn't speak English. They could sit on all this video content and immediately create new highlights and drop them on the web, and people just started consuming them. There was very little editorial restriction, like, oh, hey, this isn't going to make the Bob Costas show tonight because we only have 45 seconds and your clip didn't make it. Well, who cares? We're going to put it on the web and let the users decide. And then the last piece was Encores, was taking all the broadcast content, the really high-touch, high-quality Bob Costas work, and take that to the web as well. So fundamentally, live was Windows Media Services, and the last three buckets were this adaptive streaming or chunked encoded content. OK, so how did we get there? Well, the first thing that we did is we built this concept called the tide chart. And I could send this to you if you want. It's actually this huge, huge Excel document. And it basically maps out by hour, by day, the amount of traffic that we expected by each particular sport. So obviously, different sports have different interests. Swimming may be more popular than saber, et cetera. Every sport is different in length. So length is going to determine ultimately how much file size and how much encoder time we need. And then there's this concept of concurrency, because we have multiple sports going on. The tide mark was 17, so we had to build out enough infrastructure to make sure that we could concurrently run our workflow. So ultimately, what it was able to do was determine the amount of CPU power, the amount of actual electrical power that was needed in our center in Beijing, the amount of cooling, right? Everyone's in the computer business here. We know what happens whenever computers don't get cold. The amount of storage, and then the amount of ingress and egress in terms of bandwidth that we needed out of our processing facility in Beijing. The interesting story about all this is NBC went through this process. They built out their encoder infrastructure. They modeled it, and they realized that with the current CPU power so that was in March, whenever they did this, in March, the current CPU power, they could not get enough encoding horsepower to hit the entire schedule. They could not, because they didn't have enough rack space to put in any more machines. So they kind of held off. Intel was working on a new Penguin processor that provided more efficiency and didn't consume as much electrical power. So they put their build on hold for about 3 months, waited until those new Penguin processors came out, and then finally shipped everything on a boat end of May, early June. Took about 6 weeks to get over to China. They unpacked everything, turned it on, and they were like, OK, we have enough infrastructure to do this. But without this tide chart, we're kind of lost. And this was a very interesting lesson that we learned. A lot of people come up to us and they're like, "How the hell did you pull this off?" I'm like, it all started really with this, because then this was the game plan that we had to hit. It drove scheduling, it drove advertising, fulfillment, et cetera, and it also drove all of NBC's infrastructure requirements. That tide chart then also influenced what we did on encoding profiles. Day one, whenever we started the Olympics, we got a bunch of email from people like, hey, why isn't this full screen? Why aren't you delivering higher quality video? We like the video, but why isn't it bigger? Why aren't you delivering higher bit rate? Well, it really came down to a couple of different things. First of all, the IOC, the International Olympic Committee, has restrictions on how much real estate you can use on the screen to deliver video and then also advertising. And it's roughly around 20 to 25%, depending on your layout. So right off the bat, boom, we were out of full screen mode because it was difficult for us to do complete full screen, but also have advertising inserted into it. You couldn't do overlays. They could only be banners or companion ads. The next piece was, well, given that, the kind of the least common denominator on the web would be 1024 by 768. And oh, by the way, we also had restricted bandwidth coming out of Beijing. So we roughly had one 40 meg DS3 line where we could channel all of the content that I just showed you on that tie chart. We fundamentally had 40 encoders doing all that work. So we basically had about 1 meg per event or per encode session that we can use. And that's how we came up to this, where the live and rewind for high mode, we were delivering 650K streams. For low mode, which was those side windows in the video control room, we were delivering 350. And for picture-in-picture, we were delivering 50K. So that's 1 meg right there, times 40 encoders. We basically maxed out the capacity in our DS3 lines. The other thing we didn't know is we really didn't know how hard we could push on the end consumers' PCs and how much last mile was going to be able to afford us in terms of all the ISP infrastructure across the United States. Because we could have reconfigured a bunch of things and said, all right, for certain events that were really popular, we're going to try to drive 1.5, 2, 2.5, 3 megabit. But if the last mile wasn't there, or if PCs weren't, a good majority of PCs weren't going to be able to play that back, then why take that risk? So in the end, this is the model we came up with. We all agree it was pretty conservative, but it delivered a great experience, and the majority of people were happy with it. Alex Zambelli, he's one of the guys on my team. You can go look at this blog post that he did. This was towards the end of the Olympics, and he went into much more detail around the encoding profiles and how we made most of these decisions. So where do babies come from? So the first thing to understand, in Beijing, there were multiple cameras at each event, but the IBC, the Chinese IBC, they controlled access to all that video. So as all the video came off all the sporting venues, they were funneled down into this international broadcast center. And there were folks in there doing line edits, basically like cut from camera 1, cut to camera 2, display some information about the score. And then they basically scored it out some HD PAL source that NBC and other content rights owners picked up. In this case, NBC then took those HD PAL source and drove them into 40 individual digital rapids encoders, targeting the profiles that I just showed you on the previous screen. And then we dropped them over to 2 Windows Media Services instances running on 2 separate Windows Server 2003 boxes. And the nice thing there was we had these 40 encoders just cranking out video, and we barely put a dent in those 2 Windows Media Services boxes that basically took the WMV streams and converted them into live HTTP streams. Then what we did was we then took those, ran them across the DS3 line that I showed you. They went to New York to 30 Rockefeller Center, where they had basically mirrored Windows Media Services boxes behind their firewall that they could control. Like if there was an oh crap moment and they needed to shut down a feed, they could shut it down right there. But then that got patched through to the DMZ. So they had another set of Windows Media Services boxes, which would then ultimately reflected out to the CDNs. Within the CDNs, in this case, Limelight and Level 3 had built out massive server farms of Windows Media Service boxes to then ultimately deliver video to clients. So lots of content, down to encoders, down to 2 WMS boxes, back out. You can have these slides, and you can print this out and talk to people about it. This is fundamentally what I just showed you. So, we showed this to other people in a meeting, and they're like, just show us this, because this is a lot easier to understand. So what I just talked about was for live. At the same time, literally under our feet, because we were on the 9th floor, on the 8th floor, there was a bunch of other stuff going on. So we had rewind encoding of live, so that was being routed through similar processes. And then getting pushed out to CDNs, and I'll talk about that in a minute. We had this highlights factory thing going, so we had all those interns sitting there creating highlights. We had Encore publishing. We had people making scheduling changes. We had people doing ad booking. And what you see here, this is a slide of all the systems that NBC built and or glued together in order to handle the workflow for the Olympics. And there was roughly about 8 individual systems that they had. and it was an integration nightmare. So what did they do? They already had a bunch of Windows servers hanging around. They had SharePoint server licenses, and about 3 guys in a truck spent about 2 months and glued the majority of those systems together with a workflow system using SharePoint. And it was a really, really nice story. We didn't even know that they were doing this. We kept on asking them questions like, hey, how do you have insight to what's going on with these systems? And then they finally came back and said, hey, we built the SharePoint server system, and they had this unified model of, as all of that content was flowing through the system, we could walk up to SharePoint and say, okay, this is what was going on with scheduling, this content was pushed out, this content needs to be republished. So I don't have better screenshots because this was their secret sauce, and I'll leave it to them. So, how they pulled this off, though, and this ultimately impacted a lot of the player development, is they came up with a common message schema, just like good developers should and do often, not all the time, but often. They came up with a common message schema to, as SharePoint was monitoring all these systems, as SharePoint was managing all these systems were basically pushing little messages back and forth. They weren't SOAP messages. They were just little XML text files saying, hey, this is the job that I'm about to do. I just completed it. I'm going to hand off to the next person. And that was all codified down into a common message schema. We already talked about this with the highlights factory. One of the interesting things here is that in this middle section right here, the little workstation, all the interns were sitting at Avid workstations, and what they could do is actually look down into all the low-res content that was coming out of Beijing, plus all the content that had previously been produced, and come up with an edit list, and then kick off an encode job. Let's say, okay, this is all the content that I want in my video. I'm going to kick off an encode job. And as soon as they hit publish, it ran through the encoding process that I talked about. It created the manifest file. It pushed it out the CDN. And then voila, within about 15 minutes, it showed up on the site. It was a very, very interesting model, whereas before, they may have had to do an encode, put it on tape, do some type of manual file transfer. It was really interesting that they were able to automate all this. So the last piece of this, before we get into some of the player goo, is what we actually did with publishing. So we functionally had 2 CDNs that were delivering this content. So once encoding and chunking was done, we used Signient, which is basically a file transport technology focused on the media industry, to reliably deliver content to multiple locations. There were actually 8 different drop points. There were 2 CDNs plus mobile providers plus affiliate stations that needed to get all the content that was being produced. So Signient drove all that workflow. And then it ultimately then called out to Akamai. Akamai was the site that hosted the actual NBCOlympics.com and said, hey, there's new content available. So Signient was kind of you could basically equate it to being kind of RoboCopy plus BizTalk server combined, sitting there orchestrating the transfer and workflow management. So that's how we pulled off these 4 content types. Now, what ultimately happened at the player level? Well, we had 2 players. And personally, and whenever we did our postmortem, this was a pain in the ass. We had to go build 2 kind of identical players at a base level because we had to meet business requirements. But fundamentally, at an architecture level, it was really difficult because you're dealing with a JavaScript, Windows Media Player environment, and then you have this really nice, elegant Silverlight experience. And then, oh, by the way, we have to interact with Flash and a bunch of other JavaScript that was controlling the site. But the motivations for WIMP were real simple. We wanted to have the least friction as possible so we didn't lose customers. And then for Silverlight, we wanted to do things like pip. We wanted to do overlays. We wanted to have better navigation, all the things that we couldn't do inside of Windows Media Player. We wanted to do adaptive streaming. So functionally, what we ended up building was a system of, and I'm going to walk through what these files are, a system, as that workflow system was working on content, it pushed out a new kind of index file to the website. And the index file said, hey, there are new videos that are available. Whenever I clicked on a particular video, then a JSON file was then sent back to the player. The player parsed that information. The player, in this case, whether it was Windows Media Player or it was Silverlight, parsed the JSON file and then went and grabbed the video and started doing playback. If there was commentary associated with it as well, it then went in and started pinging the folder source for the commentary file that was coming out of Beijing and would do the UI synchronization. I'm going to go over here and do a demo of this in a minute. So the first time the player loads, whether it was WIMP or Silverlight, we went out and basically pulled this XML file. This GUID right here is the unique GUID generated by the content management system that correlates to a particular video. And then the JSON file was really kind of the Bible. You know, it was delivered to the client. It had all the information that the players needed to do video layout, to control scrubbing. The advertising information was booked in there, and then ultimately the URLs were encoded for the video. But they weren't the actual URLs. Because what we had to do for the players, both the Windows Media Player and the Silverlight player, one, we had to do geofencing, and we also had to do tokenization of video endpoints so people couldn't deep link straight into our content and start hijacking it and syndicating on other sites. So the first thing we needed to do was we implemented geofencing, and I'll talk about this a little bit more at the CDN area, but anytime a request was made back to the CDN, the first thing that the CDN did was check your IP address. And if you failed an IP lookup, we sent a message back to the client, and Windows Media Player or Silverlight said, hey, sorry, you're not in the United States. Given that NBC only has rights for distribution in the US, you don't have access to this content. The more significant thing that we did was tokenization. So the URLs, the ones that I showed you, this is kind of the friendly URL of the actual video. But every time a JSON file was served up, we went and tokenized that URL based on time and a secret key with a TTL of about 2 minutes. So you could take this and pass it around for roughly around 2 minutes, and you could get access to the content. After that, the URL expired, and it would look like, from a player perspective, that the video never existed. So really, kind of where do babies come from, or how does video get ultimately to those players, is the following. So we loaded up the player. We parsed that JSON file. We used edge side includes at Akamai to do that calculation and insertion of tokens. So we had to go to Limelight and to Level 3 and come up with our shared secret and our hashing mechanism. And then Akamai did the calculation and insertion. The players then handed back that URL that it thinks is the right URL. And then it says, OK, give me the video. And then we go back to the CDN. They do a geo check. If you pass that, then we go ahead and do a token check. If you pass that, then the CDN responds with, here's either the access to your WMS live server for live content, or here's the manifest file for the chunk content that I'm going to play to you. For content protection, we took this one step further. So for non-live content, we handed back a manifest file. And that manifest file was gzipped and then also encrypted with a private key that only a couple developers knew. It was hard. The decode was hard coded into the Silverlight experience. That manifest file ultimately provided the pointers to all the individual chunks that made up that video. And then ultimately, Silverlight plays back the URL.
Question?
Yeah.
Is it for legal reasons that the geo-check isn't done first, so you don't waste time with the user?
Good point. Yeah. So the question is, so to answer your question, yes, we were doing geo-checking before this as well. So yeah, if you came, the first time you actually opened up the player and you went to a particular video, we did geo-checking there as well. But and then anytime you try to play any video, we also did geo-checking. Yeah. You could still get access to the site. That was kind of the confusing things to users. Like, you could still get to NBCOlympics.com, you could still surf around, but then boom, as soon as you try to watch a video, then you got restricted.
How did Windows Media handle the manifest file?
Oh, hold on to that question for a second. So your question was, how did Windows Media handle that manifest file? Good question. I'm going to walk back into player architecture in a little bit more detail in a couple minutes. So For the CDN delivery, going through that workflow that I just showed you, there were some other things that happened. We used two CDNs. We used Limelight and Level 3 networks. Limelight was the lead. They served about 90 to 95% of the traffic, with Level 3 serving about 5%. We call this a hot backup situation, where Level 3 was fundamentally serving the exact same content that Limelight was. They just weren't serving as much traffic. The reason why we did this was, given that we started with no content and we had to build up caches and build up this whole content base, if you will, over time, there was no easy way to build out kind of a cold start model with Level 3. So from day one or day zero, we started serving traffic to both. Some complexity there, though. One, we had to make sure we had the exact same URL structure. The CNAME attributes, like token authentication and geo-restriction, which I'll show you in the next slide, that all had to be the same. Oh yeah, the content had to be the same, right? The same content showing up in two different places at the same time was very important. That's why we use Signiant. But what this enabled us to do was really have very, very fine-grained control beyond just having like a nice hot backup, very fine-grained control. And we actually tweaked this process using this GUI in the middle called Level 3's Internet Traffic Manager, or ITM. It's basically a bunch of rheostats where we could dynamically control traffic, and we controlled it across a bunch of things. So whenever you requested a video and it was going to go get the JSON file, we could control where you would go get that JSON file from. We could control where you would get manifests from. We could dynamically point more people to Level 3 for live content and more people to Limelight for on-demand content. And a couple times we actually turned the rheostat completely one way just to troubleshoot issues with a particular CDN. It was very, very helpful. But it required some work up front to basically have those two systems mirrored. So how did we get there? How did we get all this workflow done, the CDN work done, understand the types of encoding profiles? Fundamentally, NBC started this process last June in earnest. They started building out what the IBC center would look like in terms of square footage and the amount of racks and what types of ingress and egress that they would have. We met with them a couple times in November at CES. That was the first time we basically showed what the user experience was going to be like. Bill Gates in his last CES keynote said, hey, we're partnering with the Olympics, or NBC, to basically break the mold on the Olympics. This is what it looks like. And that was the first time where we had designers doing wireframes and mocking up XAML and trying to use Blend at the time, because we were still in beta mode, to start building out the experience. We did the traffic forecasting. And then in May, that's whenever we dropped our first beta. And we did a freeze. We did another beta 2, synchronizing with Silverlight 2 beta 2. And then we went live on 8.8. There's a massive amount of work. The reason why we put this slide up here is because there was a massive amount of work done in a very, very small amount of calendar time. Architecturally, and this is the short list, these are all the people that we had to work with. And I'm going to quickly walk through this. So at NBC side, I think you get the point. There was a lot of workflow and vendor coordination that happened there. At Microsoft, we had our team, our Edge Computing Network team, that was helping us on the CDN side. We worked on this new adaptive streaming piece. Oh yeah, we also had to deliver Silverlight 2 beta 2 to market. We had to work on demand generation through MSN. We built up a monitoring infrastructure that I'll talk about in the end. We also had to work with a company called Delta Tray. Delta Tray was basically the frame that you saw on NBCOlympics.com that the Silverlight and Windows Media Player experience was plugged into. It was the CMS system that controlled all that. Delta Tray, this is very interesting. They have some of the best technology on the planet to do real-time scoring for live sporting events. And they have lots of work in soccer and in the race car industry. So it was a natural fit for NBC. They've used them in the past, so they can integrate all the real-time statistics into the Olympics experience. Unfortunately, or fortunately, depending on how many times you got to go to Italy, we were in Redmond. NBC was in New York. They were in Italy. We had people working in LA, people working in London. It was a huge logistical problem. Schematic, they were the agency that did all of the player work. So they did the design plus the Silverlight implementation. They did a great job coming up with, there were things that we could still do to tweak it, but given the time, given the budget, and given the constraints we had, I thought they did a really good job of basically coming up with a simple model to expose all this new content in a way that had never been done before. We talked about Limelight Level 3. DR and AnyStream, we actually use Digital Rapids for live and an AnyStream encoder for all the on-demand and rewind content. Signient did all the synchronization of distribution of the content to CDNs. We worked closely with DoubleClick, so all the ad inventory that we had in the system was delivered. The in-stream and companion ad inventory was delivered through DoubleClick. We worked with them to build a native Silverlight 2 API to program against to do delivery and tracking. Omniture sat around the entire application to do site and player metering and analytics so we could walk up and see what was happening on a day-to-day basis with traffic. Keynote was used to monitor all of our Windows Media Services and adaptive streaming, so looking at beyond what the CDNs were providing us, more detail about the health of WMS streams, things like buffering and consumer quality experience. And then we also used Slicked, which actually monitored the publishing points, all those WMS publishing points, so we could get some insight of what was happening with WMS. And really, at the end of the day, Windows Media Services was not bothered by the traffic that we put across all the publishing points that we had. So, collaborating with all those people, we then started with our player design. We did start classic kind of wireframe, basically passing PDFs around. This was a shot from about February, if I believe. We did all of our user interaction in line on these pages. If things change in meetings, these documents were updated. These became the kind of de facto point of what and why and how the application behaves. There was no, oh, hey, Bob in that email said he wanted to change something. No, it all got codified back into our wireframes. And then we immediately went over in March, and we started porting all this into XAML and into Blend. And then we got out of the wireframe and Photoshop game from there, and then marched through development until we went live in August. So ultimately what we built, well, we built a lot of red because, one, we had to. So everything that you see in red was basically things that we did to integrate with Windows Media Player and then with existing JavaScript infrastructure that was on NBCOlympics.com. And then we ultimately built the Silverlight player, and we bridged the two using scriptable methods inside of Silverlight and DOM communication between Silverlight and Flash to Silverlight, and other services on the page. The interesting thing about Silverlight is whenever we started the app development, it was really all about the presentation layer. What was the video window going to look like? What happened whenever I clicked the buttons, et cetera? But then we started layering new things on. So whenever we went and worked with DoubleClick, they said, yeah, we'll build out an in-stream API for you. So we dropped in this new thing called the Dart DLL. We wanted to do adaptive streaming. So another product group, and we now have released that to market, went off and built this adaptive streaming infrastructure. So we dropped this eLive library into the Silverlight app. We had ad model logic that we worked with NBC on, dropped another library inside of there. We realized we needed better logging infrastructure, so we dropped another library inside the Silverlight app. And that was the beauty behind the Silverlight development experience, is because as we needed new things, just like building an enterprise app, we had a highly object-oriented model for the actual core presentation layer, and then we just kept dropping more objects and more libraries into the app. Actually gonna, I'll do that at the end. So I have some code and some other things I want to show you. So as we got into 8.8, or really 8.6, everyone was pretty much freaking out, to be honest with you. We had people in New York, and we had people in Beijing, communicating daily basis, getting ready. We had all types of kind of game plan development ready to go. NBC did a really good job of they implemented this kind of all-up view for critical systems that they built. So that slide that I showed you with all the systems, they could walk up to this dashboard and look at CPU utilization on a particular machine, power management, et cetera. A fly couldn't spit on a particular machine without them knowing about it. And it was really cool because, spindles would go bad, people would trip over cords. They had this mechanism to manage what was going on with the core engine. But that was only part of the story. This was all about delivering video. So we had to then go to the CDNs and say, hey, what can you provide beyond what you traditionally provide to help us monitor architecturally around the quality and health of video delivery? So they came back with their typical stuff like, well, we can show you concurrent streams. We can show you how much outbound traffic you have. We then kind of dug a little bit further. We realized that 404 errors were really important to us because sometimes content would get published, but all of it wouldn't be there. So users would go and click on something, and they'd get a 404 error, and the CDN would see that, but we had to then correlate that into a graceful experience for users and then notify our publishing people, because then at that point it wasn't a computer problem, it was a human problem that needed to go fix. So we had to rely on the CDNs to provide us better information there. Cache efficiency was really important. So the concept here is as content is getting pushed out to CDNs, they first drop into their origin, which is kind of like the base of content. And then as people request them, depending on what region you're in, it'll get pulled out to the appropriate cache. So the origin may start in, say, southern Texas. And as people in northern Maine ask for that content, it's going to get pushed to the CDN's local kind of edge cache. So cache efficiency was really important for us because as we pushed out new content, cache efficiency would be horrible. Everyone would be going back to origin, and the user experience would be horrible for a couple minutes, depending on how many people hit it and from what regions. So we had to look at the cache efficiency to see, well, yeah, caches were filling up appropriately. Caches are healthy. Sometimes we had to refresh a cache, so we had to see how long it took for a cache to recover. It was very important for us. But the thing that we realized was, okay, we had the engine management and we could look at video delivery coming out of the CDN, but we had millions of people watching content with Windows Media Player and Silverlight, and we really didn't know what was going on the last mile or on their desktop. So what we ended up doing was implementing two features or two kind of libraries inside of the Silverlight client. One to look at bandwidth, so we could make sure that we were hitting a sweet spot with our encodes. And this was a report that we got back. And ultimately what happened was we were able to push up to around 1.5 megabits with our adaptive streaming technology. But we left about, what's your 16 plus 35? What is that, 51? Is that right? Yeah, 51. So there was a considerable percentage of people that had more bandwidth, that had more perceived bandwidth on the client than and we weren't taking advantage of that with the encode rate for the video that we were delivering. So reporting like this was very helpful for us too, because then we could say, all right, next time in the future, we can make different decisions. But what we really did, this was probably the most important thing, was we built a real-time telemetry system that basically gave us across the board, like video starts, if people were buffering too much, if ads failed to load, how many people got geofencing issues, how many people got 404 issues, how many people had just a general exception error. Silverlight 2 Beta 2, great product. Sometimes it just blew up, right? So we need to know these things because, at the scale that we were dealing with, if there was a major problem, we had to be able to go back into whatever system and fix it, whether it was Silverlight or it was Dart or Limelight, et cetera. So we had this aggregate view, and then we could drill down and look at, here's a report. This is basically looking at rewind content, and there was a clip in particular here, this men's group CIV versus Argentina. We had 6 failures on that across this given time period. So then we were able to look at, okay, we're seeing some patterns, and then quickly drill into what was going wrong. And the client was reporting back, like in this case, we were getting media failures because there was a missing manifest. Like the manifest for that chunk content just simply didn't exist. Somehow it got published, but the manifest for the chunks weren't there. How we pulled this off was actually Roger Doherty, one of the other evangelists in our group. He's a SQL Server guru. I called him up about 3 weeks or 2 weeks before the Olympics and said, Roger, I don't feel right. Like, we have all this data, but we just don't have a full view of what's going on. So we went and built this implementation, dropped some WCF goo into the client. We built out a server farm at OrcsWeb. We had 10 servers, I think. Yeah, 10. Yeah, okay. 10 to start with, and then 15, fronted with a load balancer. And then we queued this all off into SQL Server Service Broker. So basically, as those Silverlight clients were gathering log information, they went through the load balancer. They went out to these 10 and then, or ultimately 15 servers, running IS7 and WCF and SQL Server queues on the front end. And then we pushed all that content back to a data tier and then ultimately into a data warehouse. So as people were watching those videos or having errors, we were able, within about 5 minutes, to see, oh, okay, in aggregate or in detail, these are the problems that we were having. I'll hit this slide and then kind of go over to some code. So the last thing that we did was we basically set up a 24-hour war room. And people from New York, Beijing, Phoenix, Redmond, Torino, they were all on the phone. They all had access to all the real-time reporting that I showed you. And the interesting thing, and this was a lesson that we learned, was we had all these people, and we never ran into a problem that we couldn't solve, number one. Sometimes it took longer than we wanted to. And we had all these real-time systems, but given the amount of people and just the geographic distribution, sometimes certain people didn't know what other people were doing. Like, they knew that, yeah, Bob, he works on advertising, but really didn't know all of Bob's workflow. So if we're trying to triage and he didn't understand what Bob did, it took longer to get done. You had a question? Sorry.
Yeah, it's related to the cache. You said you were back to caching, but you should do that caching.
Yep.
Is there any particular technology that you're using or proprietary cache?
Oh, so the cache efficiency, that's actually kind of some common reports that you can get from both Limelight, like any CDN. They will provide you those. The interesting thing, like those, like they have a whole host of reports, and until we ask them, like, hey, we need those cache hit reports, and we need them to look a certain way, they didn't understand until we asked for them, and like, yeah, this is the exact why, because we're having some problems with content propagation, or certain people are just seeing content starting slow. They're like, oh, yeah, sure. Yeah. All right. So just to end up with, the code, all the logging code, this telemetry code, we can provide to you. Roger and I were talking about posting this up to Codeplex or something like that. But fundamentally, what we did is we built out a configuration model. So in this case, we didn't want to kind of overload our logging system. So we did things like, here's the number of max errors that you could send, the max number of seconds to open a connection and close a connection to a server. In essence, what we did was we tried to get a WCF implementation to be as efficient as possible, because the player was doing 14 other things, right? It was going and playing video, it was serving ads, it was doing other tracking. So we want to have minimal touch to the client. So we built out this config, and then the logger itself basically had one static method. Oops, that's not right. There you go. So we had one static method called log. The developers of the player, we provided them an error object. It goes back to the same kind of schema that we came up with for all the workflow across all the systems. We came up with this concept of error. Whenever you were inside of the Silverlight development environment, you just create an instance of a new error, fill up a bunch of parameters, call log. And this system was built based on the background worker thread. So one of the interesting things in Silverlight, you can do a bunch of work. The majority of that work happens on the UI thread unless you go ahead and spin off these background worker threads. Very important to do here because we were communicating to the WCF service. So we had a background worker thread to log locally and then talk to the service. One of the other things that Roger and we spent a lot of time on was trying to get the communication model to be as lightweight and as kind of not chat-free, but as terse as possible. So we went in and mucked up or altered the XML serialization. So instead of here passing things like human readable names over, like session good, et cetera, we just use 1 or 2 characters. We made them attributes. So fundamentally, we shrunk down the method schema as much as possible. And then on the server side, we basically had a WCF method. We ended up reaching out into the ASP.NET context to grab header and IP information. So we had to run this in compatibility mode. And all we did was basically deserialize that information coming from the client. We added some additional information into it, like IP address. So here I'm just deserializing. And then I handed off a new message to Roger's infrastructure on the service broker side. And boom, we were done. On the player side, we had this concept of player core.xaml. Most of those methods, the methods on the player, like play, pause, volumes, change, et cetera, they were all scriptable because we had to have parity between what was going on in a Windows Media Player environment and what was going on in a Silverlight environment. So we made most of the public methods scriptable. And we also built this concept. So now this page right here was this kind of the core part of the player. And then we had this concept of the playback controller. So anytime something happened, we had this object called player settings, and we would wire up a new event and say, hey, the latest event that just happened inside of me was the following. So then someone could look at this big list of events and see, oh, okay, these are the last 6 things that happened on the player. And then ultimately what we did was we came up with a very large config file to basically control dynamics on buffering, ad booking, ad playback, et cetera. So instead of us having to go and recompile the actual application, we could just go to this config file and change player behavior. This became very, very helpful. Interestingly enough, we were probably doing a build a day, if not every other day, of the actual player and dropping it out to the site, which was another thing that was very sickening at times, especially like as we got into like day 7, day 8, day 9, people were coming. There was events that we knew were going to drive lots of traffic. How did we get around that problem? Well, we had a mirrored staging environment. We drop it to staging. We'd get a bunch of people to pound on it, and then we'd flip the switch and push it over. Fortunately, we never had to pull back a build. So. Getting close to on time. How many of you have used HTTP Watch before? Okay. So HTTP Watch, this is a tool you can go buy it. The simple version that's free doesn't really do a lot. This is the professional version. Basically what you can do is, let me shut this down. And I'm going to clear my log. I'm going to go back and replay that Phelps video. I'm in record mode. It's basically a plugin it runs in Internet Explorer and also in Firefox. And what it does is it just sniffs all of the HTTP traffic that's going in and out of the browser. Right now I have a filter turned on, and I'm filtering on JSON requests. So I showed you that where do babies come from video or workflow. This is the JSON file that got returned for the Phelps video, and I can go in and look at all the information. This became incredibly useful during the Olympics because we were going in and sometimes there were problems with URLs. Maybe someone fat-fingered some metadata information. But HTTP Watch or Fiddler, some other tools out in the market, became very, very helpful. So, all right, lessons learned. How many of you have written RFPs in this room? Requests for proposals. Documents to get paid. Okay, got it. So the first thing, recommendation. And most people are experiencing this today. You know, scrumming builds better teams. We definitely found that scrumming helped us tremendously on this project for a couple reasons. One, we are geographically dispersed. Two, we were working with about 6 different vendors. And you know, God bless, everyone has their own individual business to run. But at the end of the day, whenever you're working on a big project, everyone has to be on the same timeline. Scrumming really helped snap everyone to that same timeline. Like, look, every Friday we're having a build done. Here's the features that we're getting done. It was a good model. The other piece of this, though, was meeting face-to-face was really important. Phone conversations, even video conferences were nice. And the reason why I bring this up kind of in an RFP positioning is that it costs extra money, right? It costs extra money to buy plane tickets. It costs extra money for hotels, et cetera. And especially in these financial times, people become T&E adverse. I encourage you, if you're working on a big project, book in this time. Add another 15 or 10% to the budget, and then explain why this is so important. It really helped us, and I think if we didn't do this, we wouldn't have been as successful. Next piece, everyone should know all rules and all architectural touch points. It became evident after a while, because things were so complex in that workflow, that you may be having a discussion with someone and you had no idea what the hell that they were talking about. You knew that Frank or Bob worked in a particular part of the company and their role was to do X, but if you didn't know architecturally how his or her work affected your work, it was more difficult for you to get your job done. This point really came out of our post-mortem of what we were doing in that 24/7 triage, because we're sitting on those calls and someone was saying, oh yeah, this is how such and such works. And we're like, no one knew that, right? We just knew how the overall model worked, but we didn't know maybe specifically how one piece of it worked. I've already said this. Creating that common schema for the workflow between all those systems and then ultimately at the player level really reduced a lot of complexity. If we needed to change metadata about a particular video, that cascaded through the whole system up to the player. This was a lesson that we learned after the fact once we looked at the data, was even whenever traffic volume started to decrease towards the end of the Olympics, and especially after the Olympics were over, the unit number of videos grew. And what ended up happening was we think we hit the right sweet spot with the UI to make the long tail work. We provided an environment where people didn't have to jump in and out of a particular player or go through some pagination model to find new content. We used metadata to display like content so that people could continue to snack over and over again. So it's important. If you want to go drive some type of long tail experience, really focus on the UI design. It's just not enough to have a bunch of content sitting on a server. Next piece, okay, great, long tail, we proved it out, but the long tail delivery model hides issues. This goes back to the work that we did really with the CDNs, where at times we were so focused on the next Usain Bolt or Michael Phelps or US basketball game, focusing on that particular quality delivery experience, that we forgot or lost sight that, oh, hey, someone was having an issue with a Taekwondo video or a saber video. So building the right telemetry and monitoring systems was really, really important as you're looking across this kind of long tail, massive breadth of content that's sitting in not only one, but in 2 CDNs. This next point, which kind of dovetails with this, we just flat out need better telemetry and monitoring solutions. This seems to be just a byproduct of the web, where everyone basically said, well, I use Omniture for this, and I use Gomez for that, and I have basically vertical stovepipes of monitoring for a particular system. But whenever you have to pull those systems together, you can integrate them, but you also need integrated monitoring and telemetry. Chunked workflow presented new challenges. Windows Media Services and live streams, we've been doing that for years. It's rock solid infrastructure. People love it. People know how to use it. It works well. we got into this whole chunked or adaptive streaming model where we were taking files and chunking them up into small pieces, creating thousands and thousands of files that had to then get moved to a CDN, presented a whole new set of workflow challenges for us. And what we did there, and this kind of leads into the last lesson learned, is fundamentally we had a solution to basically chunk that video and play it back inside of Silverlight. But what we didn't have at the time was some good infrastructure and technology to manage that chunking process and the storage of those files. So what we did was we took that technology and we rolled fundamentally how it behaves and how it works into IIS 7. And that was the announcement that we made yesterday with this new smooth streaming technology that we added through IIS Media Pack. So what you can do is basically hand off a particular video, and IIS 7 smooth streaming will help fundamentally do all that chunking and storage and management of the content for you, so you don't have to worry about it. And the last piece is, I think we left some on the table in terms of bandwidth and video profile estimates. So you saw before, I showed on that graph where there was a lot more bandwidth and basically space where we could push higher quality content to consumers. Ironically, we learned that lesson almost immediately because the day after the Olympics, we did the Democratic National Convention. We used Move networks to deliver the video to the Silverlight player, and we did up to 3 meg encodes, and it turned out that the sweet spot for delivery was just over 1.5 megabits. So it was nice. We're like, okay, yeah, we should have probably pushed hard in the Olympics, and then, oh, by the way, we had the data, and then we just did another event that proves it out. And obviously, it's only going to get better. There's going to be more and more bandwidth proliferation. More and more people are having FiOS and better connectivity to home, more performant machines. So why were we successful? Well, we had a huge pedigree on Windows Media, so the encoding partners that we were working with, it was a lot easier for us to do. We had really strong partners. That page that I showed you, everyone stepped up and they were committed to getting this done. I think the quality of MSN's audience really helped. Silverlight, and this kind of goes back from an architectural perspective, like Silverlight was really ready for prime time at Silverlight 2 Beta 2. It still had some bumps on it. There were some things that we had to work around, et cetera, but it was really ready for prime time then. And with our release to web a couple weeks ago, it's a great platform to go build solid state, enterprise-worthy, rich media applications. And the last piece is really, like, we had the competency, passion, and resource to get it done. And that was kind of the fun part. Like, whenever we were going to go and work on this project, we said, I think we're smart enough. And everyone was like, okay, it's the Olympics. And then really pulling the right resources and being able to tap into our partners and the whole community out there to pull it off. That's ultimately why I think we were successful in getting this done. So with that, we got about 10 minutes or so. I'll open it up to questions. But thanks for your time. Yeah, go ahead.
Did you guys get the, like the Windows Silverlight was a big risk. Did you guys get the bump in terms of increasing adoption of Silverlight?
Yeah, so the question was, what type of kind of bump did we get from Silverlight install? We had about just under 8 million installs during the event. The interesting piece was we had a lot of repeat business. So after about day 12 or so, it was a lot of the same customers coming back. We had a really good conversion rate, which was also nice. Like most other kind of ActiveX install success rates are around maybe 10%. We were seeing anywhere from 30 to 40, 45% given. But that was kind of dependent upon the content, too. Like if something hot was happening, people were basically saying, yeah, I'll take it. Yeah. So
the 30 to 40% of that was Windows Media?
Yeah, people that basically fell back to Windows Media Player. Yep. Go ahead.
given the latency between China and New York, does it have to do with tweaking of the TCP/IP stack?
So the question was, given the latency between China and New York, do we do any tweaking of the TCP/IP stack? The answer is no. The nice thing about our workflow process is there was just pretty much enough latency in the system to synchronize the metadata that we had to the video that we were playing back. In fact, sometimes the metadata was there before the video, so we tweaked that at the client. We basically used media markers and looked at natural time and said, okay, we're a little bit too far ahead here, so we'll go ahead and pause on the metadata delivery. Yeah.
Can you go back to the older question on how did you handle the decryption on Windows Media?
Oh, yeah, so the question was about manifest files. We didn't use adaptive streaming for Windows Media Player. So Windows Media Player always got Windows Media Services streams either live or on demand. So that was one of the drawbacks of if you fell back to the Windows Media Player experience, you didn't get adaptive streaming. You didn't get higher quality bit rate. You got fixed bandwidth WMS streams. So we never touched the manifest file that I showed you. Yep. So let me go back and I just can show you real quick. Yep. Okay. So and I should have probably been more clear. So for non-live, and so this is only in a non-live Silverlight environment. If you were non-live and you were a Windows Media Player, you basically went this route. You went WMS. We did not have the concept of a manifest file. So. Yeah.
Some of your lessons, like you have project management communications major lessons. How many people did you have as part of the project, from developers, testers, system administrators?
Yeah, it's kind of mind-boggling. Across between NBC and Delta Tray and Schematic and Microsoft, there was probably well over 250 people involved. Yeah, and that kind of ebbed and flowed. Like sometimes, we had 3 or 4 or 5 people. Sometimes the product group was working heavily. Then we backed off. Sometimes Schematic put more resources in. NBC was really, really front heavy. And then as we got, towards July, they basically were like, hey, we're done. We're going to go to China, get a lot of our infrastructure ready.
Who was the main project management or program?
So Jason Seuss on my team was the one who basically ran, the daily triages. Well, NBC had a guy on their side that also ran. It was basically we had Jason on the Microsoft side, and we had a lead from NBC that was managing.
How did you get NBC to agree to Silverlight? Was it because you had the Windows Media Player as a backup? And how many people actually just chose to use Windows Media Player and not Silverlight?
Yeah. So really, at the end of the day, the decision was less about how did we convince them to use Silverlight. It was more about they had this kind of grand scheme of things that they wanted to do, and we looked across the board and said, hey, we think we can help you with demand generation. We think we can help you deliver higher quality video. We think we can help you just pull off this type of scale. And then we had it back into what were the minimum requirements for Silverlight. We wanted to have adaptive streaming. It needed to be shipped on time, and it needed to be, from a performance and stability perspective, even though we weren't going to be in essence RTM mode, it had to behave and perform like an RTM product. Those are basically the commits that we made to them. And since they had such a rich history in Windows Media, they used Windows Media for a lot of their other events. They know how to use Windows Media. They're very adept at VC1 and WMV encoding. It was a natural fit for them versus them having to basically back away and go the flash route and buy new infrastructure, get new people up to speed. It was more of a natural fit for them to use Windows Media.
And 40% of the people used Windows Media over Silverlight?
So in aggregate, I'm trying to think. Your question is how many people, like what was the ratio?
Use Windows Media Player versus Silverlight.
Okay, use Windows. I would say at the end of the day, we were around 50-50.
Wow.
Yeah.
How did the Silverlight team respond to the pressure of having to have this product?
Is anyone from the Silverlight team in the room? Or the ECN team? Anyone? Okay, so how do they respond? They responded like rock stars, really, at the end of the day. I've been working at Microsoft for 11 years. Scott Guthrie, I can't speak highly enough about him from a leader, both as an executive and also as a technical leader and a visionary. He was with us there the whole step of the way, both at negotiation to making commits to while he was on paternity leave, and it kind of trickled down from there, right? So usually what happens is the leader then kind of influences the rest of the team. They had great leaders inside of the team that stepped up. It wasn't really that hard of a problem to get them to snap, because it was the Olympics, right? At the end of the day, like, if we can't do this, no one can. And if Silverlight can't do it, then why would we be in this business? So everyone basically looked at it and said, let's go kick ass. Let's make sure we deliver on time. Let's make sure it's rock solid. Stay out of NBC's way.
So that means you would have to have tight control of the feature set. Like, someone wanted this, or we were supposed to try to get this control in, but we're all working on whatever NBC wants becomes a top priority.
Well, the nice thing about Mix, so you have to remember what happened during that time frame. The nice thing about Mix was a forcing function to get feature complete on Silverlight, fundamentally. So we walked into Mix pretty much feature complete on all the features that were in there, and then we were in basically triage, bug fixing, tweaking, performance mode. So the majority of the features, other than this adaptive streaming piece that I was talking about, was all in the box.
Thank you. Thank you for answering my question. Sorry,
Yep.
I took
No,
so
it's
many.
Yep.
The question is about the CDN.
Yep.
What was the cache hit ratio you were getting with the CDN? Was it really helping out? Was it taking load off of your own servers when you were streaming video?
So the question was about cache hit ratio. So to be clear, once video was delivered to the CDN, customers never touched any of our infrastructure. Customers only went to the CDN to get content. So the cache efficiency was about their ability to fill up their caches as much as possible. So that was, that's one of Limelight's, strength, is basically instead of having to come back to origin, they have this massively distributed, geo-distributed cache architecture throughout the U.S. So the thing that we were most concerned about was whenever someone was going to a local cache for content that wasn't there, and then they had to go back to origin, the delay in routing process there was a consumer experience. So that's whenever we were looking at the report. Sometimes it was horrible. Sometimes there was just problems when in DNS architecture. But most of the time, it was rock solid. So just like any type of application, especially running on the internet, we looked at things and said, oh, hey, we have a problem in a certain area. Let's go look at what's going on with that cache implementation.
So do you have any statistics in terms of how many objects were cumulatively stored in the cache over a period of 2.5 weeks when the Olympics was on?
Millions.
Okay.
For the fact that for all those videos, there were thousands of little chunks created for the adaptive streaming piece. Yeah, there were millions of pieces.
All right, thank you.
Yep.
In most cases, they operate exclusively on cache.
Yep.
So storage is just a fallback to cache.
Yep.
I have a couple questions regarding the specifics of the adaptive streaming.
Sure.
I think it was Scott Guthrie at Mix last year who mentioned it first and said that it would work based on encoding different bitrate versions of the stream, and then the Silverlight client would be responsible for choosing which bitrate to play back. But it sounds like today it's a different solution where the server pushes back the right bitrate depending on what the client. Could you clarify how that works?
Yeah. So how it works is that the client has a set of heuristics in it that looks at downstream bandwidth and CPU pressure and some other things, and basically makes a decision, I'm capable of X bandwidth, and makes that request to the server. And then the server responds with that. And then as the client has to make decisions to scale up or down, it will go back to the server and say, start giving me chunks of this different bandwidth, and we'll start sending.
What protocol is that done with?
HTTP.
Is that multiple requests being open and closed?
I don't know the answer to that.
Do you know if there's a library available today that can work both on the server side and on the Silverlight side? Can we start implementing this kind of technology today, or not yet?
So right now, we won't have that available until Q1 of next year. And then developers will have access to the library and to the server. So the announcement we made today was basically, or yesterday, was that Akamai would be going off and working on a set of infrastructure.
Is it only Akamai, or anyone with IIS can host it on the server side?
It's only Akamai right now, and then anyone that has IIS will be able to do it in Q1. We're not done yet with the product.
Cool. And one last question. How quickly or how precisely can you scrub?
How
Precisely can you scrub with this streaming technology? To the second, you said that your videos were chunked in a certain 2 minutes?
Yeah, so some of those decisions are still being worked out on. So fundamentally what happens is that the encoder will be responsible for in essence, the chunk semantics. Right now we were chunking within 2 second pieces, and you can get down to the 1/10 of a second accuracy on the player. So if your question is more like, are we going to get to frame accurate? Like, can you go and
Possibly, yeah.
Yeah. So we're not there yet, but we're working on better chunk semantics with the encoder.
Cool. Thank you.
Yep.
Given the scope and the time frame, what development methodologies did you guys use to handle change and get this thing delivered on time as it went along and hit your
if you broke
deadlines?
the build, you were fired. No.
And prevent developer burnout, I guess.
So we did a couple things. So one, we had a rifle shot test, which was at the end of May, early June. So that was kind of the first, we were doing scrumming before then, but that was the rifle shot test was all the pieces come together, we turn everything on, we do it live on the web and see what happens. So it was difficult before then because we didn't have all the systems set up to basically see if things were breaking. So then once we hit that point, then we went back and fixed a bunch of things. We did another kind of quasi, not rifle shot test, but we were doing more and more live testing. And we kept doing that all the way up until we went live. But a lot of the things we ended up doing to kind of protect ourselves is, we built test harnesses to basically emulate what was going to happen with the player. The CDNs were off doing load testing with their infrastructure to make sure that the scale that they were building was up and working correctly, that they had capacity available.
Since this was new and you were doing it as you were going, were you doing a lot of this stuff on the fly and just kind of just refactoring everything and kind of,
No, it was.
Or was it planned pretty well, and you were able to stick to the game plan?
Yeah, it was planned very well. The plan did change a lot, though. I mean, just like anything, we planned, and then we missed dates for a particular example, or servers weren't ready, et cetera. There was other priorities took precedent over something in the plan, so we kept changing the plan. But it was part of that Scrum process. Pretty much every week, we were always making progress on the aggregate deliverables. Jason did an awesome job, of basically saying, well, we lost control of this thing. Let's just give everyone 3 weeks to catch up. No, it was every day, kind of hammering the schedule, hammering bugs, and making sure on a weekly basis we were making visible progress, either with a build or knocking out really big issues. Yeah.
How large was the Silverlight application?
How large is the Zap? I think we were just under 4 megs or so. Yeah, you can go check we can do that now if you guys have other questions. It changed while we were building it because sometimes we were ripping goo in and putting stuff in and taking stuff out. Yeah.
How many of those weeks was the team working overtime?
How many weeks was people working overtime, man? I have no idea. I can tell you it was a lot of work. Yeah. I remember walking into 30 Rock on the first day, and everyone just looked like zombies. And I was like, wow, we are in for 17 days of some interesting times. But, a little bit of sleep and coffee and the excitement of doing something new was some Red Bull, yeah.